Well, let's go ahead and get started. It's 9:30. As the name implies, we're going to talk about entity framework. I'm going to talk about some of the more advanced topics, but since EF5 just shipped, I'm going to spend a little bit of time and talk about Entity Framework 5.0 for a few minutes. My name is Sergey Barsky, and I work for Magenic Technologies, work out of Atlanta office. I'm a Microsoft MVP in data platform. I've been working with Entity Framework since beta of very first version, and I actually shipped the production product almost as soon as version 1 came out. And that one is still in production after about 3 years. And so let's go ahead and jump right into it. This is a little bit of a background. Entity Framework, of course, is a Microsoft ORM tool. And now it's in, depending on how you count, either third, fifth, or eighth incarnation. I'm going to talk about code first in this session, but some of the concepts actually apply to database first approach as well. And what I want to start with is the schema evolution. Anytime you work with a database layer, sooner or later it changes. And at that point, you have to have an ability to handle those required schema changes. Of course, handle existing data, update your maybe QA, maybe your local environment, production as well. And there are a number of ways you can go about it. Prior to code-force migrations, which shipped earlier this year, you had to use some kind of a third-party tool. Whether you use SSDT, you can get maybe Redgate or Quest or any number of products that are out there that help you manage your schema changes starting from development all the way through production. Now that really changed. So if you have a lot invested into those products, you can continue doing them exact same way. So the only requirement, if you maintain schema outside of your model, which is your entity framework entities and context, which is your database abstraction, of course, you can continue doing that. You can use SSDT, as I said. You can use any other products. The only key is you have to keep them in sync. Because if not, an entity framework will encounter some non-existent column that it doesn't know how to handle, or reversal, it can't find the column that it expects. You will get an exception, of course. With migrations, you have one really big advantage from my perspective, and that is that you maintain schema and your model in the same place. And none of those other tools give you that. If you look at SSDT, which is SQL Server Data Tools, at the beta, it actually had that feature in it where it would synchronize your schema changes from SSDT into the model, but then that feature got pulled when it shipped, so it's no longer there. It might come back, it might not. But migrations will allow you to do pretty much exact same thing. So all we're going to do is jump into the code, and we'll walk through migrations. I'm going to create new project here. I'm going to pull in the Entity Framework NuGet package. And then we're going to create the schema and then kind of walk through how to maintain it through making some changes and propagating those changes to the database itself. So after I install the NuGet package, all I have to do is really create a couple of classes, and I have them sort of pre-built, so I don't have to type as much. So I'm going to create one class, which is my person class, and I'm just going to replace whatever was created here, and I just have to import the namespace for data annotations, and then I have to create my context. which is my database abstraction. I'm just going to replace that. And the last thing, I have to define my connection string, and then we'll be ready to go. And I'm just going to give it a name demo, which is going to be my database catalog. So now I'm ready to run. So if I'm starting a greenfield project, I have my entities, which is my logical schema defined. Now I need to create a database. If you omit connection string, it'll sort of work, but it'll try to attach that database to SQL Express instance, which is really kind of ugly. So I always put the connection string in there. Now if I try to update database, that of course will fail. So the first thing I need to do is enable migrations on this project. And to do that, you use Power Manager Console, which is simply an interface into PowerShell commands that ship with Entity Framework. And that way, it creates the configuration for my migrations and creates the shell of the seed method that you can use to pump preloaded data into. So anytime you initially create database, you can use the seed method to create some pre-existing data that your application needs. Now I'm ready to update database. So if I try to do that, if I try to update my database here, what's going to happen is going to tell me that I need to enable automatic migrations. So you can enable them in my constructor on my configuration class. What that does is very interesting thing. So it's trying to guess, but it's looking at your schema, it's trying to guess what it is you're trying to do. And sometimes it guesses right and sometimes it does not. If you have a very strict environment that you're working with, or very strict DBA, it may not like, or she may not like for you to rely on this guessing game. And at that point, you can keep them disabled, and we'll do them both ways. So for now, I'm going to enable them, and now I'm ready to update my database. So if I run that and I flip to SQL Server, what I'm going to see is that my database got created. Of course, my table got created there as well. And of course, I have no data in it. So to demonstrate how migration works, I'm going to add a record here. And the reason I want to do that, I want to see how my existing data survives my migrations. And you can't delete data in a production environment, obviously, not even in QA. And prior to migrations, there was no way for you to do it other than rely on some third-party tool. If you rely on what's built into Entity Framework, it would always dump your database. That was the only functionality. So now I'm ready to evolve my schema. So first thing I want to do is add another column. And I'm just going to give it date time, and I'm going to call it date edit. Something that comes in later. And of course, date time is a non-nullable type. So if I wanted to use a nullable time, I'd add a question mark here. That way, the schema would allow nulls, because that's how it essentially correlates between my property types and my column types and the column definition in general. So I'm going to leave it as is. And of course, I have existing data. So let's see what happens if I update the database here, which is really all I need to do. So once my schema evolves, I update my entities, I run update database, and I have automatic migrations enabled. I have to close that because it doesn't realize that the column got added. Let me add it back. So that may be useful or maybe not. So what Entity Framework did, it kind of guessed. Since I said the column is required, so it's trying to guess for me. And that's what I'm talking about when I said automatic migration, just take the best guess. And sometimes it works. Like for integer, I'll put in a 0, which most of the time is a reasonable number. Having date like that may not be useful. So how about I add another column? and we're going to call it DbEntity2. So now, as we see that automatic migrations kind of fail in certain situations, now I'm going to create manual migration. And the interesting part is that you can mix and match. So you can enable automatic migrations, it'll take its best guess, or you can use a combination of the two. And in this case, I'm going to use a combination. So I'm going to fire add migration command, give it a name, DbEntity2. And what Entity Framework will do at this point is interrogate my schema, compare it with my entities, and then see what the differences are. And then scaffold the differences, and it'll create a migration class that uses DB migration base class. And in this case, again, there is no default value in here. And this is where manual migrations come into place. Besides not nullable, the attribute or property that it put in there, I have all kind of other ways I can configure things. And a couple of those that we need to look at is default value and default value SQL. In this case, say I want to call the SQL function, getDate. In this case, I'm just going to use default value SQL. And at that point, I'm outside of type checking and everything else. So I'm telling the entity framework that I know what I'm doing, and I know that that function exists in SQL Server. Just put it in as a default value. So let's flip back to Package Manager console. Now run update database again. And now let's take a look to see what happened. And this time, as you can see, my data always survives the migration, but now I have the default value. And if I look at the definition, it's not that the database got migrated, but the default value actually also got defined for the future data that's going to be inserted. So in this case, I have full flexibility. And of course, if it's an integer, and you can put default value of 1. Default value for type, for numeric types is 0, but I can put 1 instead of default value SQL. I would use default value parameter in there. Now there are all kind of other interesting methods that DB migration exposes, and one of those allows you to create an index. So if I'm creating manual migrations, I really don't have to have any pending schema changes. And if I have none, it'll create an empty migration form. So I can write my own methods at that point. In this case, say I want to define an index on this person table. I can create, because I don't remember the table name, so let's take a look. It's a people. And then I have to specify the column or columns. So it has 2 signatures. I'm going to just pick one, but I could have created an array of columns, and it's not going to be unique. And then I just have to give it a name. People underscore last name, something like that. And being a good citizen, I need to define a down method. So down method is very interesting. So what it does, it reverses the initial migration. That's how you want to write it. If you omit that, and at some point you want to reverse what got applied, whether it's in QA or production or locally, if you don't write down method, it's not going to revert all of your changes. So Entity Framework will automatically scaffold those and create them for you. But if you write them by hand, then you need to be a good citizen and play nicely with it. And in this case, I'm going to drop an index. I'm just going to copy that. Now I have a migration defined, and all I have to do, again, is run update database. And that should apply my changes. Take a look to see if that worked. So I have table, and I have an indexes, and the new index, of course, got created for me. So while we're at the subject of the API, let's take a look to see what else is available of the DB migration method. because you can do all kinds of things. You can add a column. We'll talk through rename it. We'll walk through rename in just a minute because that's a pretty common scenario. And it has all kind of create column, create index, create foreign key. But there is very interesting method here. And so when all else fails, you can always write TC. So it exposes that to you. Because if existing methods don't work, T-SQL is always there. Of course, you have to figure out how to reverse that. So if you say, if you normalize in a table and you extract what used to be a foreign key into a junction table, because now you allow multiple ones, which is a pretty common schema evolution, then you have to do it here. Because there is nothing automatic that will let you do that and keep the data. That's just the key part. If there is no data, you can do it through automatic migrations. But if you have data, you have to retain it, and you have to move it from one table into the other. It's simply not smart enough to guess at something like that. And neither do most other tools. Something like that, you typically have to hand code. But the key part is that you can do it, and this SQL method will let you do all that. Now let's walk through rename. And rename is a pretty common scenario. Let's say I want to rename date edit into last modified. Something like that. So now if I run automatic migrations, what's going to happen is going to dump my column, date edit, and insert a new column, and of course it's not going to keep the data. So in this case, what I want to do is add a manual migration. And what it's going to scaffold is really not what I want, because it's going to scaffold exactly what it sees, which is I want to add and drop the column. But instead, I'm going to rename the column. And this API is very, very simple. It's an old name, new name kind of thing. And last modified is what I named it to. So instead of doing what it did, I'm simply changing what it does, and I'm going with a rename method. Now I have some data in date edit, and I'm just going to change it to make sure it actually does retain it. And now let's update the database again. So if I did everything right, check name. So I mistyped either a table name or a column name or something else. Ah, there you go. Thanks. Let's try this. It would help if I copied and pasted before I renamed it, but well, there you go. So now if we look at the data, I did retain my data and I did rename the column. So just to recap on migrations, and then we'll move on. A very, very powerful feature allows to maintain the schema and the entities all in one place without leaving the studio, without leaving your project. If you have a very strict DBA, it says there is no way I'm going to let you run that in production. Then, of course, what you can do, say you have access to the schema, and I'm going to add another column. I want to call it nickname. I mistyped that, but so now say this is my schema. Okay. Oh, static string. Sometimes IntelliSense just fails me miserably. I don't know why it can't read my mind. So now I have a different schema, and say this is what I'm trying to push to production because I'm ready. So what I need to do at that point, the only thing I need to have access to is the schema that looks just like production. At that point, I can run update database. In this case, I'm going to do something different. Say I don't remember what all parameters I have. So you can always use get help, which is a standard PowerShell command. And at that point, I can specify the connection string. So it doesn't have to be locally, because if I don't specify one, it'll look in the config file and see what I'm comparing it to. But I could give it one where I have a copy of production database. I can do that. And another parameter right now we're interested in, because our DBA just wants the script, then I can use this minus script parameter. So what I'm trying to do is run update database minus script. And I can do minus connection string, of course, and point it to some copy of production database. And then it'll open the script. So the first part is what DBA is interested in. And then he or she's going to ask you, what the heck is all this gobbly-goo that I see right after your edit column? And this is the magic behind migrations. So whenever I enable migrations, what it does, it adds the schema table, in a system table in SQL Server case, and it's called migration history, and it keeps track of what I ran. So this is how it knows what's pending. Whenever I push it out, it looks, okay, did I run this migration yet or not? And so it'll figure it out, and this is where it stores what happened prior to today. And that's what got added to my script here. It's insert migration, and the second parameter is the hash of my model, which is combination of my entities and my context. It kind of computes this hash that uniquely identifies that schema. And the hash is what's left in the database. So the second parameter in this model is the hash. And the migration ID is the name of this file. So whenever I run add migration, it's the date timestamp when migration got created, plus the migration name. That becomes the primary key in that secret migration history table. So that sort of covers it. What you have to be aware of is multi-developer scenarios. So you may run into some conflicts. So if two people add migration at the same time, and you have yours apply, and you get latest, and for whatever reason it conflicts with your stuff, then you have to somehow resolve those conflicts. It's not that much different if you work with SSDT or some other tool. Sometimes you have to resolve conflicts. So if you have a large team that constantly modifying the database, you may run into some issues with like contention on your model or contention on migrations. And this is like a typical process, but to me that drawback does not outweigh the benefits of working with migrations. Any questions on migrations?
Yeah. So obviously anything that's there that hasn't been run yet is going to get run when you do the update. How do you go back down?
Back down. Good question. So now I have this update database. Let me pull this up. And it has a parameter called target migration. Hello. See, I'll find it in just 1 second. Here we go. So target migration is the migration name. So if you specify target migration, it doesn't care if you go up or down. It'll go to that endpoint in time. So it could be down or it could be up. So if you do minus target migration, it'll go down. And of course, you can generate the script for that as well. So if I specify target migration is like 10 days old, you'll try to create a script to reverse the stuff. Of course, if you edit a column and the user puts some data into it, that column's gone. But it does allow you to reverse. So if you made a terrible mistake and you want to come back, you can go back. The other thing I did not mention, and that one is convenient probably for QA and especially dev environments. So I'm sure some of you have seen this class called initializer. In the native framework, there is one like drop create database if model changes, database initializer. So there is a new initializer that shipped with migration called migrate database to latest version, and I don't remember the rest of it, but that's how it goes. So for production, your DBA probably not going to let you do that. But for QA, and especially for devs, that's really convenient, because all you have to do is get latest and simply run the app. And it'll evolve the schema to whatever the latest version is. So for prototyping or dev environment, having that initializer is really convenient. And when you set initializer, you can surround it by like pound if debug, so it'll never run in production, or use some other compiler directive, or simply have another version of, say, global SAX if it's a web page that you're going to deploy in production versus dev. But pound if debug probably will work for most cases. In debug mode, it'll create initializer, otherwise it won't. Any other questions on that? All right, I'm going to flip back to my slides, so we'll kind of stay on track. That's what it's called, migrate database to latest version, and it has two generic parameters. One is your context, and the other one, that configuration class that got created when I created migrations. And we talked through, missed one. So there is migrate.exe, which is the command line utility that does exact same thing as update database PowerShell command. So it has the same parameters. So that's another way for you to distribute the changes. You can run this migrate.exe to propagate the changes. And maybe your DBA will like that, maybe he or she won't. But that's another way you can do it. So it's installed whenever you install Entity Framework. I don't remember. It pushes into the same NuGet folder, actually. So whenever I install the package, create this folder with reference assemblies, and also it will have migrate.exe in the same folder as well. So you can distribute that and propagate those changes. So now we're done with that, let's move to performance. So performance is really a big topic. And it's a big topic really with all ORMs. It's not just exclusive to Entity Framework. You're not going to find an ORM that gives you the same performance as a raw ADO.NET, because they all add some overhead too. So what I want to talk about is mitigating that overhead. So a couple of things to be aware of. One, doesn't require any code, which is caching of the metadata. Excuse me. And it's more important in web environments. But it works exact same way for desktop apps as well. So whenever I spin off the context and I fire a very first query against the database, whatever that query is, what Entity Framework does internally, it hydrates all the metadata that goes along with your model. And by that I mean it has to create the mapping schema, because it knows your model, but it has to know how your model maps to your database. It can't work without that. Same for all other ORMs. They all take this exact same hit on the first query. They try to figure out, whenever you manipulate your object model, what query to generate. Exact same approach everywhere. If you have 3 tables in your database, that probably takes negligible amount of time. If you have 200 tables in your database, you will see some hits start to slowly accumulate. And it could be 2 seconds, and it could be 5 seconds. And if you hit like 1,000 tables, it could go upwards toward a minute, depending on how far your database is from your app server and how complex your schema is, how many columns your tables have. And I've seen it hitting like close to a minute on a 1,000-table database. What it does, however, at that point, it caches all that metadata in the app domain. And it doesn't really matter if it's a desktop app or it's a web app. As soon as app domain goes down, that metadata has to be rebuilt. So in a desktop app, that happens when you shut down the app. So if you shut it down, start it back up, first query, you've taken a hit. There's just no way around it. In web environments, exact same way. So let me show you something. Let me run the IIS here, right here, and I'll look at the application. So in web environments, and I'm going to look at the predefined one. So in web environments, your app domain will be recycled when your app will recycle. Those two go together. That's what controls your app domain. So this is a default IIS. I didn't do anything. When I installed IIS, I installed .NET. It defined the default recycling schedule for me. It used to be 20 minutes in IIS 7. At least Microsoft got a little smarter, and now I think this is about 28 or 29 hours, somewhere in that general area. So if you're writing a web app, and you deployed it, and the first user hits it, that user is going to take that hit. It could be a few seconds. However, every 30 hours, that next user is going to take that hit. So one thing that I would suggest is to recycle the app domain when there are very few users in the system. ideally, you'd write a little Windows service or some other utility that would hit your site after the app domain is recycled and just fire a random query to force that metadata to be repopulated. So you minimize bad experience for your users through controlling this recycling and maybe helping that. Sometimes you don't have to help it actually, because in iOS 8 there is a module, I don't remember what it's called, but it's like application warm-up module, and you can install it in 7.5 as well. So what happens, that application will be warmed up by iOS itself. It'll simplify your global LSAX file. And so if you have something in that file that touches your schema, they'll warm it up for you. And if you don't have that, you can write maybe a scheduled task, like write a little command line that queries some random table, put on a scheduled task, so it'll run every 30 hours. If you're going to stick with the schedule, warm up your database right after that. So it's a very, very easy, and you can help that user experience a little bit. So now let's talk about CRUD operations. So I'm going to pull up the same app I've written before, and I have some data in here. So I'm going to just simply query that data. And I'm just going to create context. And I'm going to query my company, well, whatever I call it, person, yeah, people, to list. And I know I have one row in it, so I'm going to just simply rely on that. And what I'm trying to write out, I'm not sure if you're familiar with this entry method on the context. 0 state. So the entry returns the DbEntity Entry object, which has all kind of useful information about this specific entity. So what I'm interested in at this point is the state of my object, which is my person, right after I fire the query, which does a couple of things. First, it creates a query against database, pulls the data using reader, and then rehydrates that data into my object, which is person object. So what I'm going to get out of this is the list of people. And then I'm going to add console.read key, so it'll stop. Oops. Going to run that, so I have one row. Hopefully I won't get no reference exception here. But that will illustrate the point. Yeah, I did. Aha. I guess I did not run the last migration. So let's do that. I'm going to update database. So that's what happens when you forget to do it. You'll get an exception. The entity framework will remind you that you did something bad. So the state that it comes in with is unchanged. So what that tells me one thing. My context is tracking that entity. It knows it's in an unchanged state. So if I'm binding to those entities in a desktop app, like WPF app directly, I'm not going to argue whether it's a good idea or a bad idea. But say you do that. This is exactly what you want. So if if user changes something, all you have to do is fire save changes, and the changes are done. They persisted to database. Most apps aren't like that. Adventure, I guess 99% of apps aren't like that. Web apps definitely are not like that. So what's involved into tracking? So the context will attach some event handlers to all the entities so it knows when a user touches. Overhead of that is not ginormous, but nonetheless it's an overhead. So there is an easy way to get around that overhead. And there is extension method on dbSat called as-null tracking. What that does, and if I run it, you will see what it does. The state is detached now, meaning that entity framework DB context doesn't care about this entity anymore. So you eliminate this overhead. And granted, the overhead isn't big, probably a few milliseconds. It may be more if you pulling in maybe a couple hundred entities because that's your page size. So with with 10 letters, you can cut down that overhead. So like I said, it's not much, But if it's that easy, why not go through all that trouble? So now let's do something different. I'm going to change this to first, and we'll talk about updates. As a matter of fact, let me look at the portion record, see what columns I have. I have a bunch. So what I'm going to do is create a portion. And what I'm trying to do here is sort of illustrate how web app would work. And I have ID, and I'll look up to see what my ID is right quick. And that one is 1. And then I have date edit. I'm just going to do datetime.now. And first name. And I have last name. Let's see what else I got. Same thing. And the last property is nickname. I'm just going to say whatever. So say this is, I'm running a web app, and this is what got submitted through form post. Now I'm trying to do something with that data. So what I'm trying to do is update it. So I can use something like a find method, and I'm going to pass person.personID. So what find method does, it finds an entity based on a primary key. And like there doesn't seem to be anything wrong with that code. I can do this at that point. Last, I'm just going to change 1, first name. Or you can use automap or whatever else if you want to pump the data, so you don't have to write all that much code. That's pretty typical code. If I run that here, one thing I forgot to do is flush the changes. So anybody knows what's wrong with this code? Let's flip to IntelliTrace. Let's see. All right, what's there? And we'll see what's wrong with this code. So what I'm trying to do is do an update. Here's what find did for me. Find actually fired a select statement to grab that data from database, rehydrate it into the object, and then hand it over to me, which is what it's supposed to do. Now, in relative terms, select comparing to an update statement is much more expensive in any database. It requires a lot more work on the part of the database. So how do we get around that problem? Because what I'm trying to do is simplify an update. So we're going to take that code out, because that's not what we want to do. And we're going back to the same state method. Let's see what I'm doing here. Person. So I can pump the data in and then simply set state to modify. So if I run the same code again, if I look at the IntelliTrace, there is no select. This one just did a migration check, this select, but there is no select. And if I fire save changes, here's my update code. I just got fired. So with just one line of code change, I can go from inefficient code to very efficient code. And it doesn't matter if you use find, if you use first or default, you have exact same overhead in all of those. Now, how about delete? So deletes, you can do exact same thing, except you don't need all this stuff. So I can write code like this. Because Entity Framework, when it comes to deletes, all it cares about is primary key, and if you have a timestamp column, then a timestamp. So at this point, I can run this, and it should fire my delete statement, and all it compares is the person ID. So I could actually have UI that sends over just the ID and a timestamp in case I want to do concurrency checking. And it does exact same code that it did before, but in much more efficient way. Any questions? So if you use an entity framework, entity in services, and you may or may not want to do that. I mean, maybe you want an isolation level between the two, but it's kind of tempting. If you already have this stuff, why not return it? Because that's what WCF Data Services does. Right? It does the exact same thing. It's using your entities because it exposes them via service interfaces. So if you use service interfaces and you use entities in those, what you have to be aware of is a couple of things. One is lazy loading. So let's talk about lazy loading for a minute. So lazy loading is a great feature. Anybody knows what that is? So I don't have to rehash the same stuff. Let's reverse that. Who doesn't know what that is? Nobody. So we can skip over it. So if you are in service environments, you have to disable that, because the way serializers work, they walk through your properties. So if you have lazy loading enabled, as soon as serializer touches the property, it's going to get loaded. So it's going to start serializing that. And then it hits some other navigation property, it'll load that, so it starts serializing that. So that the chain will never end. So whenever you're working in services, you have to be aware of that weird behavior. Proxy creation. Anybody doesn't know what proxies are in Entity Framework? One bite. So it's the same thing with proxy creation. So if you define a service that returns person, it's not going to know what to do with dynamic proxy underscore person underscore xxxx. So you can write a dynamic resolver, which is a pain, or you can simply disable proxy creation. So you do both via configuration property on the context. We can glance at it right quick. Yeah, so we're in the context. I can disable lazy loading and proxy creation, which is also slightly faster as well. So sometimes you can even disable those and have slightly faster code. So that one pretty fast. Let's flip back to the slides. The other downside of lazy loading, and something you have to be in general aware of when it comes to performance, is that you don't want to fire too many queries. Here's an example. You want to get a list of people, and each one, say, have, I don't know, sales orders attached to it. And you want to print the count of how many orders they have. So say you use lazy loading, and you have a web page, and you simply building out a low grid that has first name, last name, and number of orders. So if you have lazy loading enabled, and you simply query people, and then you loop through that, and you output first name, last name, and then you output orders table.count. Legitimate code. If you have one person, then it's one extra query, because lazy loading will actually populate the data. Say you have 100 people. So now instead of firing one query to populate the grid, you're up to 101 query to populate the grid. So in general, you have to be aware of lazy loading and use that feature wisely. And the typical guideline is, if you know what you're outputting, then you want to use eager load, meaning you want to explicitly say, I want to load this child table because I need data from it. And if you don't know what you're doing, because you may need to look at some flag at a person and decide which one of those navigation properties you want to interrogate, at that point lazy loading is more efficient because you don't have to load both sides in advance. You can load the side of navigation that based on your if kind of decision tree that you're doing. So that's a typical guideline. If you know what you're doing, always use eager loading. It's always faster. And the other side topic with that, if you just need the count of orders, then don't load the whole table. Because all you need to count, you can create one query that will be more efficient. It'll execute count statement on the back end instead of loading the navigation properties. Now I'm going to jump into version 5, which shipped, I guess, a couple of weeks ago. And so it's in production state, RTM state, I want to talk about. So Entity Framework in version 5, which shipped with .NET 4.5. So try to keep all that version straight now in your head. So when you do that, they spend a lot of time working on performance. That was one of the primary goals in the team, is to improve performance. And that took many shapes. One was to simply improve what SQL is generated. So that improved performance a little bit. The other thing is, in DB first approach, there was a feature called compiled queries. So when you use compiled queries, you typically put that into a static variable, and what it does, it creates the plan, meaning that it's going to look at the tree, expression tree of my link statement, and it's going to translate that into T-SQL, actually, using whatever provider you use, whether it's a SQL or Oracle or whatever. So that process actually takes some amount of work. Could be a lot of work if it's a complex link statement. And what compiled queries used to do is cache them. Well, rephrase that. You cache that because you put that into a static variable, so you can just reuse the same query over and over again, and you reuse the same plan. It was still smart enough to let you specify parameters. So you can compile query with parameters, then you feed just parameters in, and it still reuses the same plan, the same T-SQL. However, in CodeForce, that feature was never implemented. Like you simply couldn't do it. So instead of putting compiled queries in CodeForce, the team went with the automatic auto-compiled queries, meaning that any query you fire, that will actually cache that translation, the T-SQL, along with some hash of the actual link query. Again, supports parameters, so it's smart enough to deal with parameters. And it'll reuse it if the same query comes along. So the cache, however, it's not infinite, so there is some limit on it. And then the runtime will actually periodically sweep the cache after it reaches a certain level, and it will evict the queries that have been, I think they use LRU approach, MRU, less recently used, whatever. So the queries that was accessed at the longest time in the past will get evicted first. And so unfortunately, it's like you can't control that node, which is sort of annoying because modern servers, they have so much RAM, who cares? I can cache 10,000 queries for all I care, they're not that big. But instead, that value was sort of hard-coded in, and you just have to deal with it. Nonetheless, in typical applications, you're not firing more than 800 queries in any reasonable period of time, and that's the limit. So once you hit 800, it'll start the eviction process. On the positive note, you get this performance for free, and you don't even have to redeploy your app, which is really strange, assuming your app is on 4.0. And that's because 4.5 is an in-place entity, not entity framework, but .NET framework upgrade. So when you install it on the server, it'll stomp on top 4.0. So at that point, even though your app targets 4.0, it'll actually run in 4.5 runtime. And it will take advantage of auto-compile queries. So that's a really good news, because if you upgrade your servers, you get instant performance boost, and you don't have to do it. The other thing that takes a while is so-called view generation. So view generation is this T-SQL, a generic T-SQL that any ORM will generate, so it'll be easier for you to translate your update and your select statement against the tables. So they look like giant select statements or giant update statements, is what those views are. And if you have like 1,000 tables, as I mentioned, the view generation can take maybe 20, 25 seconds. And when it's done at runtime. In Database Force, you could download T4 templates that you could run before compiling, and you shift that load toward compile time. And that load, like I've seen literally spin-off time going from 1 minute to like 8 seconds. Like it's a huge performance boost for any large database. And in CodeForce, you can do it by downloading this power tool. So if you go to Studio Gallery and you search for Entity Framework Power Tools, which is currently in second beta, you can simply right-click on your context. Show you. Let me flip back, find that. So if you right-click on the context and through Entity Framework, menu, you see generate views, which right now is not going to do anything. So it's not going to do anything because Studio 2012 actually broke the power. But there is a documented workaround, fortunately. So if you go to that Entity Framework Power Tools site, it'll tell you to rename one secret registry key, run that and rename it back, because if you keep it like that, then something else in the studio will break. So these two independent tools seem to use the same key for different purposes. So something to be aware of, but you can script that out, whether you use PowerShell or write a little command line that'll do that. And at that point, you can actually take advantage of the feature with just a little bit of workaround. Hopefully, that'll be fixed whenever it ships, hopefully soon. But the view generation is a very easy step that will speed up your initial warm-up time quite a bit. And since it's so easy to do, there is no reason not to. Well, we talk about lazy, eager loading. Then there is a giant white paper. It's like literally 30 pages long that the whole Entity Framework team collaborated on. And it covers performance improvements in 5.0, but it also covers what those improvements evolved, and it also talks a little bit about some of the pitfalls that you can fall into and how to avoid them. It's almost like too long, in my opinion, for what you need to get out of it. I could have compressed it into maybe 2 pages, but they have these giant graphs with comparisons, and it's really, really long. But you can compress it to maybe like 6 rules that you follow. And that's how easy it is. So just read it. It'll give you some good knowledge into insight of the .NET framework. Consolidate that stuff and just follow those rules. It's really, really hard, really easy. We talked about DbEntity Entry object already, because what I used is the state property of it to manipulate the state. While I'm on that topic, you can write very, very generic code, as you saw me do it, because you can write one method that does insert and the update and a delete that takes a person object. All it does is sets a state on to whatever state you pass in. So in my opinion, setting a state instead of using add method or remove method or attach method is much cleaner, results in much cleaner code that is much easier to follow. It's more consistent. So setting that state property is probably the easiest way to do it. It has all kind of other methods. All of them carry some overhead, so I'm not going into it very much, but one of them is kind of useful, is get database values. So if you write in a history, if you're maintaining a history and you don't want to use triggers, and a lot of DBAs hate triggers with a passion, you can use this get database value and do comparison on the fly and do your own history log without triggers. There is some overhead because you have to select that classic, obviously. But you can write history, kind of generic history framework without using triggers. So that it's kind of useful. Then let's talk about hierarchies. What hierarchies allow me to do is maintain logical schema model and translate it into a database structure by specifying the hierarchies. So I'm going to switch to pre-built demos because I want to get all the topics in and just show you the hierarchy stuff. So I have essentially 3 classes. So I have abstract class that is person, and I have a couple of inherited classes. I have developer and conference attendees. They're all built on top of each other. So what that results in is a very, very clean structure that is easy for C# developers, or VB, as it may be the case, to follow, and it's very, very logical. Entity Framework is smart enough to translate all that into the database structure. By default, it'll put all those classes into a single table. And there is one good reason why it does that. And that's because the performance will rapidly degrade as your hierarchy becomes deeper. And It doesn't necessarily use joins as we would expect. A lot of it is used in subqueries, but joins would run you into the same trouble. After 4, 5, 6 joins, you will see that your performance in any database will degrade very, very rapidly. It's across the board. So while you can maintain hierarchy, it's a good idea to put them all in one table for performance reasons. And what is interesting in that entity framework, you don't have to specify where clauses anywhere. It's smart enough to figure out what you're trying to query and construct the where clause that is appropriate to query in that specific hierarchy. See if it's simple, but you can do select query where you select from developers versus attendees. It appends dynamic where clause to query that table where all the data is stored for you automatically. So the only reason I want to mention hierarchy because they provide a way for you to organize your model a little bit better. But complex types, on the other hand, is very, very useful feature that you should really use. Let me show you how it works. Here, we'll flip to an existing app here. So complex types are essentially our classes that are not mapped to database directly. So I can add a class, let's call it address. And all I need in it is, I'm just going to stop at street. Actually, let's add one more, it'll be more clear. So we're going to call it city as well. Yeah. So far it's pretty simple, but now what becomes interesting is when I do this. So now I have a complex property, which is a type property, that will map directly into 2 columns, in my case, in a database, but it's not going to create a table. So it's the difference between me putting that address into a table versus simply using columns from it. Does it make sense? Let's run that. Let me just run update database. Hopefully it'll succeed. So now let's look at columns. So it's added this couple of columns. So far it's kind of useless. But now imagine that you have a company table that also has an address in it. So what that allows me to do to extract common properties into a class and have a consistency in terms of database structure across the entire database. So you have address in multiple tables, they all be the same size, they will all have the same rules, and I can specify one time on my complex type. That's the huge advantage. You can have much more consistent structure. The other stuff, let's just switch about so you'll know that the feature is there. Entity splitting is the way for you to map single entity to 2 tables. So you can put some columns on one, some in the other. Where it becomes advantageous is when you store blobs. Because a lot of DBAs will frown if you put blobs into some wide table. Because at that point they don't have flexibility to put these giant data chunks onto a separate drive that is accessed less frequently, for example. So a lot of them will say, if you use blobs, put them into its own table. But from your perspective, you want to access them like one entity. So there is the feature that allows you to do that. You simply create mapping that will map certain properties of a class to certain type columns in a different table versus all others. You of course can have helper properties and classes that you can exclude from the database structure, meaning you can have, I don't know, full name that combines first name and the last name of a person, and then you can either use not mapped attribute, or you can use .ignore method on the configuration and exclude from the storage. But it's there for you to still use from the entities. It'll always be populated, assuming that your getter populates it, of course. Explicit mapping is another neat feature that's very useful when you deal with legacy databases. They typically will have names that existed there for a couple of decades when a maximum column size was 10 characters or 20 characters, 30 characters. So if you're writing a new app on top of that legacy database, you can use very meaningful class names and property names, and then use table or column attributes to map them to a short name. So you have more readable code that still maps to the database without any problems. Of course, all relationships are supported. The only reason I want to mention that, if your DBA will allow you to cascade deletes, there is no attribute for that, so you have to drop to configuration, manual coding configuration, and you have access to, once you get handle onto relationship, you can turn on cascade deletes. Now, this is a topic that I want to definitely cover and show you an example. Working with views and store props. Like, to me, using entity framework is not an either-or proposition. You obviously want to use as much as possible because it saves you time. Some use cases, they simply it just doesn't. Whether you have extremely complicated store proc, or it's a legacy database and has business logic in it, and you don't really have a choice, you have to call it, or you have a view that you use combined maybe like 4 tables, and then exposes them as a single consistent view, and you want to use that view throughout your app to have consistency in terms of data selection, so you don't have to repeat the same link query multiple times. You can very easily drop down to that level with entity framework. So the only thing you have to do, if you use migrations, you use that SQL method, for example, and you have to script out your create view, because you can create it in SQL Server, then generate the script and just paste it in here. It's the same with store props. So to create those, you use the SQL method. But now that you've done that, to use views, all you have to do is use the SQL query method. Let's see, here's a view. Use SQL query method, and you can materialize your views into objects just like you do with normal entities. So you don't have to drop down way to raw ADO.NET if you want to supplement, because you can reuse the same database, same connection, same context that you're running within, and you can materialize the views. All you have to do is create a helper class that can be used to materialize the stuff. So it's not your entity. It is simply a class used to materialize the views. Because you can call you can call a store proc, not just you, with the same SQL query. Everything is parameterized. Like all methods take the parameter array. So you can create parameters just like with ADO.NET. You push them in, and it will materialize the stuff for you. That's to me is the big advantage, because if you drop down to raw ADO.NET, then you have to operate with readers, and you have to read the properties and all the other stuff. Where if you use SQL query, materialization, meaning reading data and translating into objects, is done for you. So that's a big advantage of relying on entity framework instead of dropping another level down. And for store procs, it's just like ADO.NET. There is another method named execute SQL command. Again, it's the same text that you would feed to SQL command. There is no difference. And you specify the parameters, and then you feed the parameter collection. It'll happily execute that. And of course, if you have an output parameter, you can use those. And those will be automatically populated. In my case, I have this one. Parameter direction is output. So after you execute it, the same parameter object will have a new value that database generated, so you can read it straight in. So the key point I'm trying to make here, it's not, you can always drop down to store procs if you need to. The problem that I see with that approach, if you do it all the time, at that point, why do you use an entity framework? Like you're taking an overhead for no reason at that point. But if for occasional use, you can always do it. So if your DBA say you have to call this store proc because I've written and optimized it, and you can't use the link query because it doesn't translate quite right, you can always do that. running a little low on time, but let's create a repository. So when you write entity framework classes and you use something what I used in here, not here, where's my sample app? And I use read or update. What this does what it does for my app, it kind of blends the layers a little bit. So my business objects now are aware of my persistence layer. Because even though the entities are persistent ignorant because they're Pocket classes, but DB context is not. DB context is exactly what it is. It's a persistent entity. It's responsible for saving your data. So typically what you want to do is write a repository. So let's just write one, just to see how easy it is. So we're going to create a class, and it's going to be an abstract class. And I'm going to say of T, where T is DB context. So now all I have to do is in the constructor I can say, let me do this. And then I just need to create an instance. And the other way around. Is there a new mod? Oh yeah, I need to create another one. It's complaining because it doesn't know if T is as a class. Oh, new, right. My bad. This should work. Here we go. Now I'm going to create an insert method. Public T entity insert of T entity T entity entity. So this is typically what I'm trying to do, and in here I can say context dot entry entity dot state equal edit, and I can say context dot save change. And I think I need to define entity as class. Now it should compile. Oh, I need to return. Return. So now I have a generic method. So now instead of writing another class, I can write something like this. Oops. Where am I? Class. Okay, here we go. Public class. Carriage. Context. And now in my program, instead of using this, I can do this. Oh, Mike. I have to implement iDisposable, which I should, because I need to dispose of the context. Disposable. And here I can just do context. Oops. Yeah, hold on, let's create a whole diff. I'm in the wrong class here. Now I'm playing nicely. And now here I can say context dot insert first. And the last thing I want to do That's it. That's it. So I just wrote generic repository. There is no, nothing about my persistent layer just bleeds into my business layer. It's a generic class. I can put an interface on it. More, I can make it a repository that implements insert of T, update of T, delete of T, maybe even save changes. Maybe I want to do batching. So I can create a repository, do a bunch of insert, then do save. So with this is how easy it is to write a repository class and give you much cleaner separation. Not only that it's not that much code, but this code is now short because I write less code in. So I moved those 3 lines of code into its own class. Let's see the time. I think we're running, yeah, a couple of minutes. Still, so I want to talk about other providers. So important thing to understand about Code First is that it builds on top of database first approach. So any provider that works with database first should be in the operative work just fine with Code First. The only exception to that rule is migrations. So migrations take a different provider. So hopefully people will start writing the migration provider, because like I said, migration is using the same provider model, but it's a different interface, so you can implement on the same class or a different class. There are not that many things you have to implement, but if you look at DB migration class, it'll give you an idea what you need to implement. So you need to implement add column, rename column, delete column. All those methods you see, they need to exist in the provider where they can translate that into the proper query. Having said that, even ODP.NET that supports Entity Framework, which is an Oracle native product that shipped last December, will work with Code First. So if we want to see the demo of that, interestingly enough, you write exact same code. So here's the Oracle one. And the code that I write, it's the same context. It seemed to have problem resolving the factory. That may go away, but at least the Oracle providers seem to. So all I have to do is explicitly create the Oracle connection. That's the only code difference. So it has trouble reading in the connection string and using a proper factory to create correct connection for whatever reason. That may or may not be the case with other providers, but this one does. Then I'm using explicit mapping. That's what I was talking about. I use configuration to change the mapping. So my country class does not look anything like this class over here. So this HR, if you install Oracle Express, it just ships with it. So I have 25 countries here. So if I run this, I'm going to run it. It's the exact same thing. So I retrieve my 25 countries and just prove the point that we can still add and save. I just added a new country. So I should, after I refresh my data, should have 26, and I do. So which kind of proves the point that existing provider will work just fine, but you should really test. And ODP, for example, they officially say they don't support Code First, and because they don't really support migrations. But I haven't seen it fail, so it might work for you, but you can't take that lightly, the fact that they say we don't support it. And if you really want supported product, in case of Oracle, there's DevArt and DataDirect. In case of other, like MySQL and DB2, those providers are done by companies typically that write the database. And as far as I know, none of them officially support Code First yet for whatever reason. So DevArt is the only one that says that, but it's kind of hard to read the exact verbiage on their pages. And we're exactly at 1 minute away, so I'm going to wrap it up. If you have any questions, here's my email address. If you want to write down my blog address, I'm going to post the slides on the demo project once I get back home to Atlanta. Tonight, I'll try to post them if you're interested in downloading, if you want to see how Oracle stuff works or any other concept, let me know. Shoot me an email. If you have any questions, If you live in Atlanta, Magenic is hiring, so if you come want to work for us, I'm into 30 seconds pimp your stuff portion in case you haven't noticed on my talk. 30 seconds isn't bad. And I'm working on an online course on Entity Framework with Campus MVP, which is a training site. It should be out by end of September in case you're interested. So I'll leave it here for a minute if you want to write down my email address. And questions portion of the talk. Anybody got any questions?
Is there any way that before you leave, you go back to the white paper
Sure.
URL? You don't have to change them.
There you go. And if you write just my email address, I can email it. I can email a link as well. If you want to write a little less.
Is there any chance that you'll post the Camtasia version of this presentation?
Good question. I can't. I just figure out. Well, I'll probably YouTube it because it's free. So if I YouTube it, I'll put it into the same blog entry as a link to YouTube video. Since I'm recording, I don't guarantee the sound quality. Typically, it's not great, but Camtasia does allow me to remove noise, so hopefully it'll be decent enough after the noise removal. And I'll for presentation this long, I'm probably going to take it an hour to process the file, and hopefully, I don't know how long it takes me to shove it into YouTube and get a link, but I'll do that.
I have one more question just about in the Framework 5's capabilities. We've been using it in Hibernate for years, waiting for the framework to mature, and we have the ability to subclass. So we have like an interactions table that has a type, and we use that type as a discriminator. And then we have different POCOs for each of the discriminations. And so let's say we have an interaction table, and the interaction types are all different. And then we have a class called external interaction 1 and external interaction 2 for the different types of things we want to log. And so that we can keep those hierarchical in the C# code, but flat in the database. Does the Entity Framework have a facility for doing that?
Yeah, it does that. The hierarchies, if you look at the hierarchies demo as part of that, that's what it does. So it has C# hierarchy, but flat table in a database. And you can do a reversal too. You can map each level of hierarchy to its own table if you want to, but as I mentioned, you have performance issues at that point. Too many joins, and it just starts sucking, especially if you have hundreds of thousands of rows, it sucks badly at that point. So you want to avoid hierarchies that are too deep. Any other questions?
Actually, on a previous project that I was working on, we have a stored procedure that returns multiple return sets, result sets, and I thought that I read somewhere that Entity Framework 5 was going to be able to handle materializing multiple result sets into different entities. Do you know what that is? I never heard anything about it.
No, I don't think that's done because there is no API for it. Because you would have to use SQL query, and it's a single generic of T. So if they were support that, it would be of T1, T2, T3, T4, one per result set. You probably write it yourself. Actually, it's not.
There's a codeplex.
There's code. Somebody already wrote
it. It is exceptionally slow.
Exceptionally.
Yes, it is quite slow.
That's probably because they don't optimize materialization. So when Entity Framework does, what they actually do, they cache the C# code or dynamic code that they generate on the fly because they don't use reflection. What they do, they generate classes and dynamic DLLs that they load and run, and then they cache them. So that's why their code is faster. Alternatively, they could probably rewrite it using like reflection.emit, which is 100 times faster, and you have to cache. So my guess is they use pure reflection, and they don't take any steps toward optimization of that. And if you do, there are a couple of ways you can do. You can use expression trees and compile those. Those will be pretty fast after you compile them. And you can cache those per type. Or you can use a reflection.emit, and that code is really, really ugly, but it's also really, really fast. using that. And
I was hoping somebody would do it for me, because I don't really
Oh.
have a whole lot of time to do it myself.
yeah, I don't think they've quite done it yet. So I
Yeah.
think
I got a question about how the migration map the constant value